Hello, my dear students. So, with respect to our last class, we have successfully completed with our module 4, wherein we have come across with what do you mean by classification as a term and different classifiers along with the problem examples there. Okay, so now today we will come across with clustering. Okay, so this I can just say that this is a little bit quite similar to the term called as classification, but it is not classification as compared. So there comes an clustering as a term. So wherein clusters are created across with the data sets what I have with me. Okay, so wherein I'm creating across with a group of similar kind of objects, I group them together and I call that as one single cluster. Similarly, I group up some similar propertied objects and then I call it as an another cluster. Okay, so wherein in this particular section we are getting to know what do you mean by cluster, what are the different types of cluster, features of it, then different types of clusters there, then example algorithms for each and every one. So let us come across with clustering as a term. Okay, so what is this cluster analysis? Finding groups of objects, just now as I said, you finding groups of objects such that the objects in a group will be similar or related to one another or different from or else unrelated to the objects in the other groups. They are either related to the objects within a particular group or else they are unrelated with the objects in some other groups there. So here by this particular example, by this particular figure, you can just find that there are three clusters which I'm mentioning here. These are the objects which are related to one another and they don't have any kind of similar relationship with the object in another cluster there. Okay, so this is about your cluster analysis there. Okay, so within and respective within the objects whatever is been lying, I call it as intra-cluster. Okay, intra-cluster distance are minimized here. Okay, so as I have a lesser propertied distances are nothing but the features which match up between the objects. I togetherly club them up and I call it as one particular cluster there. Okay, so whereas the relationship across between and one object of one respective cluster to another object of another cluster, I call it as intercluster. Okay, and here we try to maximize the distance what is lying between them. Okay, so that is all about your cluster analysis there. Okay, let us come across clustering is an such a field which happens to or else a cluster analysis is most important in many of the applications there, not in one or two. Okay, so wherein it can play a role with respect to your financial related things there, else it can be any related issues with respect to medical concepts, or else where you are summarizing and some related information where I'm finding across with I'm having a huge set of records and I have to summarize the data. So there also your cluster analysis plays a very important role. Okay, the main applications of your cluster analysis involves in understanding group related documents for browsing. It can be okay, else proteins that have similar functionality. I group stocks with similar price fluctuations. I trade them. I group up them together and I say that okay, these are possessing me common properties. So let me call this as one cluster. Okay, else even an application of cluster analysis is helpful in summarization, wherein I have a huge set of data with me. I will reduce that particular size there. Okay, as I said to you just now. Okay, where or else what is not cluster analysis? Do not mistake it with cluster analysis. What are those? One is simple segmentation. That is where you are dividing students into different registration groups alphabetically by last names. Okay, so I do not call it as cluster analysis there. That's a segmentation. Okay, results of a query wherein you are expecting similar kind of a results. I group them together. Okay, do not mistake it with a term called as clustering. Groupings are the result of an external specification. Clustering is a group of objects based on the data. Okay, supervised classification. What do you mean by that? Have a class label information. Okay, so that's called out as your supervised classification there. Okay, then I have association analysis, local versus global connections. I do not in any of these fields, I do not relate it with the term called out as cluster analysis. Okay, notion of a cluster can be ambiguous. Keep that in mind. I cannot have, if I have these many, now if I have, these are my data with me, data sets with me, I cannot straight away say that only these many clusters can be formed. Okay, so those cluster formation can be ambiguous. There can be two clusters, or else there can be 6 clusters which can be formed, or else there can be 4 clusters also. Okay, it is entirely dependent on the kind of data on what you're fetching it. Okay, so based on just now here, as I said you, that let it be with your intra-cluster distances. Okay, as and when I find a minimized intra-cluster, so straight away I'll be classifying it as one cluster there. Okay, so ultimately where I have an inter distance which is between the objects is maximized one, so then I call it across as that is an cluster which is object of an cluster related to an and the respective cluster there. Okay, so that's why it can be ambiguous. Okay, what are mainly the divisions of types of clusterings are? There are two types of clusterings. Keep that in mind. Okay, one happens to be partitional set of clusters, and one more happens to be hierarchical. Partitional is nothing but it's a division of your data objects, okay, into non-overlapping subsets there. Okay, such that the best example for this partitional clustering is your KNN. Okay, sorry, no, not KNN. It is with k-means clustering there. Okay, KNN was an of course it means one and the same. Here KNN also follows a similar rule there. Again, one more happens to be hierarchical clustering. That is a set of nested clusters organized as a hierarchical tree. Okay, in your hierarchical clustering, you're coming across with agglomerative clustering there, an algorithm, okay, which supports your hierarchical clustering. And in partition, you guys are coming across with uh, k-means as an algorithm. Okay, so partitional clustering. So what do you mean by this? Now I have these as my original points. I say them that these two are clusters. Okay, and this is a partitional clustering, I can call it. Okay, so else what do you mean by hierarchical? Okay, I have multiple traditional hierarchical clustering it is. I have multiple points across in different circles there. I create an dendrogram which is being related, or else which shows me the relationship between these respective points which are lying across in different clusters. Okay, so this is hierarchical clustering. We'll come across with an example in our later sections there. Okay, so apart from that also you have many distinction, many different set of clusters there. They can be exclusive or it's non-exclusive. Non-exclusive point may belong to multiple clusters there. Okay, you cannot have a single one. Okay, yes, it can be fuzzy versus non-fuzzy. Okay, else it can be partial versus complete one, else heterogeneous versus homogeneous. Okay, entirely the clusters of widely different sizes, shapes and densities are being computed across with these different distinctions between the set of clusters there. Okay, some well defined or else types of clusters are well separated clusters, center based clusters, contiguous clusters, density based, property described by an objective function. Okay, well separated clusters are, by this I can just say that there are three well separated clusters now. Okay, a cluster is set of points, as I said you. Cluster is closer to every other point in the cluster than to any point not in a cluster. Okay, yeah, center based. Center based is somewhere nearer. Okay, now here I can just say that there are 4 center based clusters now. Okay, it's not very much needed that they have to be nearer there. Okay, the center of a cluster is often called out as an centroid. Okay, and any point which is nearer to that particular centroid, okay, the average of all the points in the cluster is being called out as the one wherein I say that all of them lie across in the same cluster. Then. Okay, so this is regarding your center based cluster. Then comes contiguity based. Okay, contiguous clusters are a set of points such that a point in a cluster is closer, okay, to one or more other points, okay, in the cluster than to any point not in a cluster. Okay, so it's been there are 8 contiguous clusters which you can carry forward here if you look across. Okay, so it can be 1 2 3 4 5 6 7 and 8. Okay, so I have nearest neighbors which are being related across, and I call them as clusters. Okay, density based. Okay, so wherein I have dense region of points with me. Okay, I have very dense region of points with me, and from there I am trying to reduce, or else which is being separated by low density regions there. Okay, so I call that as a density based cluster there. Okay, so here by this particular block diagram, by this figure, you can just come across to know that there are 6 density based clusters across here. Okay? Then shared property, one wherein I have an one respective your cluster is overlapping with another circle. So I just say that there are some properties wherein the objects within that particular region are shareable or else are possessing some common property there. Okay, so some characteristics of input data are very important. Okay, what are those? One is type of proximity or density measure. Okay, so that's density of your respective region. Okay, so that matters a lot. The second one is data characteristic. Okay, that affect that proximity. What are those? One is dimensionality, the second one is attribute type, spatial relationship in the data, distribution of the data. These are the four characteristics which ultimately affect the data characteristics. Okay, then there is one more which affects the data, and that is called out as noise and outliers. Okay, it can be noise is something which can disturb your respective clustering there. Okay, that's the region which is lying other than the cluster region there. Okay. So these are all characteristics of an input data. Okay. There are some clustering algorithms which you are coming across, as I said you. The very first one is k-means and its variant. The second one is hierarchical. The third one is density based. Okay, k-means is partitional clustering approach. Okay, wherein you are making number of clusters there. That is k usually. Okay, each cluster is associated with a centroid. Okay, each point is assigned to the cluster with the closest to centroid. Okay, the basic algorithm says select k points as the initial centroid. Repeat. Okay, form those k clusters by assigning all points to the closest centroid. Recompute the centroid of each cluster until the centroids don't change there. Okay, so this is with your k-means clustering. Okay, this is an algorithm for the same. Okay, let us now, I'll just take an example and explain you guys with k-centering, k-means clustering there. Okay, you can just come across this particular example. I hope so everyone it's viewable there. Okay, so usually they say that they'll be giving an input here. Okay, and they say that divide the given sample data in two clusters. Okay, using k-means algorithm. So they have given you a data here, that is height and weight. Okay, and they have asked you to divide them into two clusters there. Okay, what will I do is the very first thing is uh, serially name them with either with R1, R2, anything, whatever you are interested with. I have taken it as row. Okay, row 1 to row 12 there. Okay, then how are you getting across with this k-means clustering is, so the very first thing is just write down initially what is the formalization which will be using across for your, remember with the k nearest neighbor classifier there. Okay, you are using an Euclidean distance there. Okay, the same Euclidean distance formula is used here. Okay, it is xh. Okay, h stands out for height. Okay, minus h1 the whole square plus xw, that's for weight, minus w1. Okay, square. Okay, as a whole I take the square root of it. Okay, in our last, when I was telling regarding classifier, we had taken it as an observed value, actual value. Okay, observed value, actual value. Okay, here in the same way, what is a very first step? Keep in mind, the very first step is just by yourself just initialize them into two clusters. Now let us consider my first two rows as two clusters. Initialize it. Okay, what do I do it? I take it as c1 and c2. Okay, this is height, this is weight. Okay, what are the values here? 185, 72, 170, 56. 185, 72, 170, 56. Okay, if whenever I am speaking regarding this term called out as centroid, what do you mean by that? Centroid is nothing but h comma w. Okay, that is 185 comma 72. Okay, for me time being c1. C1 is one cluster, C2 is another cluster, which I have taken it as an initialization. Okay, C2 is 170 comma 56. Okay, this is your very first step. Okay, now comes what's your second step? My second step is find the Euclidean distance. Now these two I have initialized it. The next step is, this is my R3, my row 3. Okay, find the Euclidean distance between this value of height, okay, to the first value of height, first row's height. Okay, then this height with this one. Okay, then similarly this with this with this. Find me the distance, Euclidean distance. The same thing is used here. Okay, Euclidean distance of R3 with C1 and C2 respectively. Okay, Euclidean distance of C3 with respect to C1. Okay, so that is square root of R3 of H3. R3 of H3. Okay, I have just taken it for your purpose so that it will be easy for you to get well with it. Okay, minus R1 of H1 the whole square. This whole square. Okay, so this as a whole, okay, as raised to 2 plus, okay, R3 of W3 minus R1 of W1. As I said you just now here, 168 minus 185 the whole square, 168, that is plus 168 minus 170 the whole square. Okay, 60 minus 72 the whole square, 60 minus 56 the whole square. Okay, you can just see the same thing I have abbreviated here. That is square root 168 minus 185 the whole square plus 60 minus 72 the whole square. Okay, so if you solve through it, okay, just go through it. Okay, you'll come across with a value called as 168 minus 185. Just go across. Okay, it goes across as 185 minus 168. Okay, that's 17. Okay, so that is 17 here. 60 minus 72, that is minus 12. Okay, 7, that is 72 minus 60. Okay, that is 12. Okay, then you can just see that it is 12 into 12. Okay, whereas here it is 17 into 17. Okay, that is 289. Okay, plus 144, that is 433. Okay, you can just find the square root of the same. SQRT of, okay, sorry, okay, it is 433. It's 20.8. The same thing I have written here. Okay, similarly now I have found out with the C1 now. Okay, so that's with C1 I have found out now. Similarly, find the Euclidean distance, that is R3 with R2. Okay, that's 168 minus 170. Okay, the whole square. Okay, then you are finding across with 60 minus 56. Okay, the same thing you can just find out here. Okay, it stands out as R3 of H3 minus R2 of H2 the whole square plus R3 of W3 minus R2 of W2 the whole square. Okay, square root of 168 minus 170 the whole square plus 60 minus 56 the whole square. That is 168 minus 170 minus 170, 60 minus 56. Okay, what will I find it here? I'll find it as minus 2. Minus 2 the whole square is 4. 4 plus, it's here 4 again, 4 square, 16. Okay, 16 as a square here. 16's square root is 4.47. Okay, now comes here next step. Just concentrate here. Okay, wherein just have an comparison between the value which I have got it with respect to C1 and with respect to C2. One I have got it as 20.8 and one more I have got it as 4.47. Compare these two. Okay, consider the least one. Okay, and shift the row to that particular cluster. Got to know. Okay, here which happens to be the smallest one? Tell me. 4.47. Okay, when I have got 4.47, when I have done this particular calculation keeping with respect to C2. Okay, so that's why I can just say that my respective R3 can be member of a cluster called out as C2. Okay, my R3 can be the member of a cluster called out as C2. Firstly, I have initialized this. Okay, it can be a member of C2. Fine, got to know. Consider the least one and shift the row to that particular cluster. In our case, it is shifting to C2. Fine, got to know. Okay. Now, after this, what's your next step now? Next step is similar things conclude or else continue with the other rows also. But there is a condition for that before you go further. What is that condition? For that thing, now here you have got it with respect to C2. Okay, as it has said that it has given you a value. Okay, Now, my prior centroid value was so and so. Okay. Now your centroid value changes now. Okay. How does it change now? It changes with finding the average of height of C2 with the value of R3. Then with weight with W3. That is how we are going to find it. 170 plus 168 divided by 2, 60 plus 56 divided by 2. Okay, that is your step 3. Okay, now find the centroid between R3 and C2 value. That is centroid of C2. If I calculate it with H, it will be 168 plus 170 divided by 2. That is equivalent to 169. Now my centroid for C2 is 60 plus 56 divided by 2. I'll get it as 58. Now what are your updated two cluster value now? My C1 will remain the same. C1 will be with 185, 72, 185, 72. It will remain the same. But what are the new changes with C2? C2 values priorly was 170, 56. Now my latest values are 169 and 58. I have shifted my centroid. By doing so, I am going to find the nearest neighbor in a more proper way or else in a more confident way there. Okay, so this is with your updated cluster value. After this step 3, proceed with step 4 in the same way how we are done with this step 2 here. Okay, for that what you have to do here now, R3 is over now, come to R4. Find Euclidean distance of R4 with C1 and C2 respectively. Okay, but keep in mind C1 values will be these, okay, and C2 values will be the updated value of C2. Okay, so it will be like, we can just go back here. R4 is 179, 179 minus 185 the whole square, 68 minus 72 the whole square. Okay, then 179 minus 169 the whole square, then comes 68 minus 58 the whole square. Okay, what are the new values which I'm expecting here? If you solve through this, okay, just go and solve across with this, what will you get it? I'll be getting it as 7.211 and here I'll get it as 14.14. Amongst these two, which is a smaller one now, it is 7.22. As we have come across priorly also, okay, consider the least one and shift the row to that particular cluster. Here, consider the least one and shift the row to that particular cluster. In our case, what is that? It is C1. So then R4 is member of which cluster? It is member of C1. C3 was member of your respective C2 as a cluster, whereas 4 is a member of your respective C1 as a cluster. Okay. Now after this, what you're going to do now? Next one. What's the next step? Here. Have we have found new C2 values. Now with what the changes have done? The changes are observed with C1 now. Now find the centroid between R4 and R1. That's with your C1. C1 of H. What is C1 of H now? It is 185 plus 179 divided by 2, 72 plus 68 divided by 2. Okay, the same things here. Okay, I'll be getting my new values are 182 and 70. My prior values of C1 of H was 185 and C1 of W was 72. I'm getting lesser values. Just keep on observing. What are my updated two clusters value now? It is 182, 169, 70, 58. Okay. What's my next step now? Again, find the Euclidean distance of R5 with the latest updated values of C1 and C2. The same way. Okay. Just to go on finding it, you'll come across that C1 happens to be with the value observed as 2 and this is with 19.1. So what is this? 2 is lesser in our case. So that's why 5, R5 is member of what? R5 is member of C1. Like this, go on continuing it for R5, then R6. To which particular cluster does it belong? Immediately find the centroid with the same. Okay. Then again continue the same of finding Euclidean distance between the heights and between the weights. Okay. Then the one which you observe it as a least value, make that particular row a member or else that particular entry as a member of that particular cluster. Okay. Now at the end till you solve with R12, okay, this is the answer which is expected. Okay, and I wish that all of you get across with this particular answer which says C1 are with all of these rows, okay, and C2 is with a row value called out as 2 and 3. Okay, and I want all of you just take this particular example and compute the same, okay, by yourself. I hope so you have got to know with this. Okay, thank you. I'll just come back to my slide here, okay, with your k-means. This with your example of k-means there. Okay, so it says that what are the iterations which I'm getting after my after my first iteration, second iteration. Okay, this is with my third iteration, 4, 5. Okay, after my 6 iterations, okay, I just come across saying or that these are my clusters which are being formed. Okay. There are some limitations with respect to your k-means. What are those? The limitations lies with the sizes of it, densities, and non-globular spaces there. Okay. K-means has problems when the data contains outliers, that is noises. If it contains any unrelated data, so at that time it might be a failure there. Okay, fine. Thank you. In my next video, I'll be telling you regarding hierarchy. Okay, fine. Thank you.